All right, so we are getting into these sections where we are going to write linear equations for given different situations. We just finished up a section where we talked a lot about graphing when we did have it in what was called slope-intercept form here. So now we're going to take information and from story problems and from graphs and actually come up with the equation from what they give us. So this first part is pretty straightforward, all right, as long as we remember that slope-intercept form is y equals mx plus b, where m is the slope and b is our y-intercept. Now, something to pay attention to as we go. Slope is a rate of change, like something that changes. Like you've seen rates of change before, like miles per hour. So a rate is when we're comparing two things. So it's usually like how much you would make per hour, how fast you would go, a concept over time, something like that. So something that is changing based on a variable is our slope, which in a graph gives us the steepness of that slope. Our y-intercept is initially our starting point or a set amount that's not going to change. So for example, if this is a graph, our steepness is the slope, right? So this is our m, and our starting point is our y-intercept, where we would start. A lot of times we start right from 0, and then we're looking at a graph and we're comparing it that way. So as long as we can identify those two things, then we can write an equation, a linear equation based on that. So write an equation when we give you, or when somebody gives you the slope and the y-intercept. And I'm going to be using those two, m and slope, y-intercept and b. Those are going to be used interchangeably. But again, starting point or set amount, rate, something changes. So when we're looking at these examples, if m equals 4 and b equals negative 2, all we do is put the m and the b in for the m and the b in the equation. Your y and your x are always going to remain there. So here we have our m, here we have our b, so we can write that as y equals mx plus b, or in this case 4x minus 2. So again, identify your slope, identify your y-intercept, and then you write the equation. All right, so we'll do a couple here. So again, y equals, we're thinking of y equals mx plus b. So in this case, this would be y equals 2x, and then our b is a positive 5. Whatever your value is. So for b, if it's a negative, you can just put a negative here instead of a positive. Or you can put plus or minus, but you will see it as just that number there. All right, over here, y equals m, which is negative 100. Then put the x in, and our b is negative 275. And then we have it in slope-intercept form. We've practiced graphing these. We're not going to graph these, but if I did, on this particular example, I would start at 5, put a dot there, and you'd go up 1 to the right, or up 2 to the right 1, and you'd get an equation that looks something like that. And again, we're going to be taking graphs later and being able to write this equation so we can manipulate it into problems. All right, go ahead and pause this and go fill out the rest of these. It shouldn't take you too long. Okay, running through the rest of these, we got y equals m, which is 1/2 x minus 1 as our b. Y equals 2.3 x. This is a positive 5.7, so make sure we put that plus there. Y equals negative 5x plus 10, and y equals negative 6x. And then you could just leave it as that. If you want to put plus 0, you can. It's not incorrect, but you'll see it represented as just this, where they assume, if you don't see the b, they'll assume that you know that the b is at 0. All right, so again, pretty straightforward. We're identifying our slope again, and I'm going to refer this on the next page of notes, which is the rate something changes, and our b as our y-intercept, which is our starting point, or an amount that does not change. Okay, now application of this. So we have a few story problems here. So what we're going to do within these problems, we're going to identify our slope, our m, and our b in the following situations to write an equation to help you solve these problems. So this is kind of the starting point of story problems where we're going to break them down to try to come up with the equation so that then we can answer other questions in relation to it. Okay, so for this first example, it says for babysitting, Alex charges a flat fee of $10 plus $9 per hour. Write an equation for the cost y, so your total after x hours, which is however many hours it would be, because that's a variable that could change. You could work 2 hours, you could work 3 hours. All right, how much money will he make if he babysits for 5 hours? So first, if we can identify our m and our b in this, we can write the equation pretty easily. All right, now, b is our starting amount or the amount that doesn't change. If something charges a flat fee of $10, that's just non-negotiable. Hey, I'm $10 just for me to show up. So that is going to be your starting point, would be $10. Now your rate of change, your slope, is $9 per hour. Again, it's a rate. It's comparing two things usually. You know, if you work 1 hour, you get $9. 2 hours, 18, and so on. So your m here would be 9. So now taking this information, our m and b, just like our previous page, we can write this equation. Our cost, y, how much you charge, equals $9 per hour, mx, plus your flat rate of $10. All right, so now this equation is applicable to any other question that you could ask in this particular problem. One type question, they might say, how much will you make if you babysit for 5 hours? So we would just plug in 5 for x here. Y equals 9 times 5 plus 10, and we put that into our equation. So if you work 5 hours based on your rates, 9 times 5 is 45 plus 10 is 55. You would make $55. All right? So let's go ahead and try, we got 2 more examples here. In the third one, there's a little bit of a wrench, but I think you'll get the idea. So a plumber charges $25 for a service call plus $50 per hour of service. All right, so again, we're identifying our slope, so the rate something changes, and our starting point, our y-intercept. So go ahead and pause this and figure out your m and your b, and if you do that, what would your equation be? Okay, so our starting point in this is our flat rate, something that doesn't change. $25 for a service call, that's not non-negotiable, it's just going to be that. So that is our b. Our $50 per hour is our m. All right, so we have identified m and b. Now in y equals mx plus b form, we can just substitute these numbers in for m and b. So my equation is y equals 50x plus 25. All right, where x is our hours. So if you work 8 hours, how much would you make? We can just substitute 8 in for x. Y equals 50 times 8 plus 25. So again, you just type that into your calculator. 50 times 8 equals 400 plus 25. So your y would equal $425. All right, what would you make if you work 10 hours? 2 ways you can do this. You know, you get $50 per hour. That's a difference of 2 more hours from 8, so you could add another $100 to this, or probably the easier way is just substitute 10 in for your x. 50 times 10 plus 25. Again, this is your equation. This is what we're using. We're going back to. So 50 times 10 would be 500 plus 25, so your total would be $525. All right, one more equation. Pause here, try to set this one up. All right, so when we read this, a canoe rental service charges $20 transportation fee and $30 an hour to rent a canoe. Write an equation representing the cost y of renting a canoe for x hours. So again, this is our total, this is our variable of what's going to change, your hours. Our M in this situation, what changes? Dollars an hour, so 30. And our starting point B, our flat rate, would be 20. So what is our equation? Y equals 30x plus 20. All right, what is the cost of renting the canoe for 6 hours? What do? We put the 6 into our x. Y equals 30 times 6 plus 20. So we can take out our calculator, we can type that in. 30 times 6 gives us 180 plus 20 will give us $200. So Y equals $200. So if you rented a canoe for 6 hours, that's what you would pay. All right, so the second part of the question is another way that they could try to test you, but still using this equation. So how long did you rent the canoe if you spent $110 total? Well, we know that Y is our total cost. So the setup of this is we would put 110, instead of putting it in for X, which is our hours, our variable, we would then put it in for Y. So I'm going to use this equation again. This is your friend once you set up your equation. And I'm going to put 110 in for Y. So 110 equals 30x plus 20. We know that X is the time, which drives how much we pay per hour. So now all we have to do is solve for X here, two-step problem. So I'm going to subtract 20 from both sides. I'm going to rewrite over here so I have more work. So 110 minus 20 is 90, and that's going to equal 30x because these become 0. Now we have to divide by 30 to get x by itself. So when you type that in your calculator, 90 divided by 30, that equals 3. So your answer would be, if you spent $110, which includes the $20 flat fee plus $30 per hour, you rented the canoe for 3 hours. So again, another way of looking at it, if they're asking you after a set amount of time, you would put that in for X, but if they're asking you what the total is after you get this, then you would set it equal to that amount.